Okay, guys, so here is the first module that we want you to do. And we thought about how to put this to make sure you understood. So we kind of bunched these two things together. But you want to be right here where it says week 2, August 17th through August 21st. And really, the first main part of this right here is your science and engineering practices. And when you click right here, it says instructions, you will see this video that I'm making right now. All right. So we use in eighth grade science, and hopefully you've heard this word phenomenon before. We always try to introduce lessons and units with a phenomenon. And that's just a word that means something we want to figure out because that's what scientists do. And so that's how we always start a lot of our lessons out. You will have to do this in order. And we're going to start you out with a phenomenon. And when you click on it, it will open up. And you notice right here, there's a little video of something interesting for you to watch. And again, we have a little bit of text. A phenomenon is just any event that you can observe and wonder about. It can be as simple as wondering why crickets chirp or rainbows form in the sky. Figuring out phenomena is the whole basis for science. Scientists, I tell kids all the time, we in the past have been bad about just giving kids lots of facts about science. Well, that's not really how science works. Scientists have to figure out things. And so we want to try to work with you this year before we send you to high school and college on not being afraid to put yourself out there, to understanding that in science, you are often going to have times when you're not completely sure because you're trying to figure things out. And so we're going to start you out right here with a little video, and then you notice that you have some questions right here. So let me show you what this is going to look like on your end. Now listen carefully because boy, this is a big point of confusion. And if you start emailing me, I'm going to be like, oh, I know they haven't been watching these videos. All right, so I'm going to go to, let me see if it lets me do it up here. All right, so I'm going to go to settings and I'm going to switch to student view. All right, so I can see what you see. And I'll show you the same one that I was on. This is my little practice thing, all right? So here is what it would look like for you, all right? Here it is. There's the text. Here's the question. And then here is, this always confuses kids. They know they're supposed to answer the question, and they always will email me and go, I don't understand where I'm supposed to write. You have to click submit assignment. You have to click it. Watch. When you click that green box, look what happens. A text box opens up, and this is where you'll type. Okay? So you will type the answer to the questions in this box. Okay? And it's pretty cool. I mean, you can put images in there. You can do whatever you want, but you're going to type your answer and then click submit again. Okay? And when you click submit again, oh, there's my confetti. All right. And then remember, guys, right here, you'll get the confetti. And some of your parents have been asking, but it will always pop up and say submitted, and it will tell you the date and the exact time that you submitted that assignment. All right. And then after we give you that phenomenon, you're going to move through and you will do a very short activity for each of the science and engineering practices. So we have asking questions, same deal. You're going to read, watch the video again if you need to. You have to click submit assignment. The text box will open up. Then you submit again. Another practice scientists do all the time is develop and use models. Now, this one's different. This one's different. Now, watch. For this one, we are actually going to ask you to draw a model in your scientist notebook. And it says go to a clean page in your scientist notebook, title it Develop and Use Models, and you're going to draw and label a model to show what you think is happening in this particular phenomenon. Guys, it's okay to be wrong. It's okay to be wrong. That's not what we're after here. We are after getting you to think and getting you to understand that as you learn things, as scientists learn things, we go back and change our model. People sometimes get upset with science because they'll say, well, they told us one thing, and then 2 years later, they told us something different. But that's science. Science changes their models as we learn new information. But I want you to notice this time you have to take a picture and upload it. So submit assignment, choose file. So remember, you will take a picture with your Chromebook, same thing, submit assignment, choose file, and then a new window will pop up. You'll select the picture you just took. It's probably in your images or download, but it's in your files. And then you'll submit the assignment. Okay, so I want to make sure you understood that one is different. Okay. I'll put leave there. All right. We want you to show that you have some idea of how to set up an investigation. Now, we use the word investigation and experiment. You're going to hear us use those words to mean the same thing. All right. So we're going to give you a choice. We're interested in this. You're going to write how you would show us or how you would set up an experiment to try to show these particular things. So the first choice is an experiment to figure out. You're going to see in the phenomena that we have a ketchup packet inside a bottle of liquid. And when you squeeze that bottle of liquid, that ketchup packet moves up and down. So our question is, why does that happen? And so your first choice is describe an experiment that you would do to try to figure out why that happens. If you don't like that choice, here's a different choice. All right, come up with an experiment or investigation to show that two different objects of different masses fall at the same rate. And just as a reminder, mass is just the word we use in science to describe how much matter an object contains. So, in other words, if I said to you, I want you to prove to me that if I take a bowling ball and a ping pong ball, okay, those two objects of completely different masses, I want somehow you to prove that those are going to fall at the same rate. I'll give you a hint. The bowling ball and the ping pong ball might not be the way to go. But anyway, so either one of those, pick one and tell us how you would set up that investigation. And again, it's okay. Right now, we're just more interested in seeing what you can do and how you think, because we'll be doing a unit on how to set up controlled investigations and get your data analysis. We're going to review all of this with you. We're interested in seeing how you're thinking right now. And we're really just looking at getting you to understand and remind you that these are just all the different things that scientists do. We ask questions, we draw models, we try to figure out how to do experiments, and we get a lot of help. We work with other scientists and say, we're not sure how to set this up, and that's okay. You also have to analyze and interpret data. So we gave you some data because all of these things are things that scientists do. Scientists also have to construct explanations. So I thought I would give you a fun one to mess with. Here's a little tick. And it's just doing its thing, man. It's sucking some blood. So we gave you this, and then we also gave you some data. And then we asked you a question, and we would like you, based on the information in the video and this data chart right here, can you come up with an explanation for why you think the number of reported cases of Lyme disease has increased over the past 20 years? And hint, it's okay to be wrong. Don't go Google it. I'm not interested in Google. I'm interested in your brain. It's all right. We do this all the time in science. We have to come up with our best explanation for things. That's okay. And then we go and we get evidence and we see whether or not our thinking is right. Uh, I always tell kids math is the language of science. So, see, I wrote that right there again. This is just something scientists do. We just use math. We have to use math to tell our story. And so we gave you some data again, and we're going to ask you to use a little bit of math and answer that. And then the last, no, we have two more. The next science and engineering practice is engaging in argument from evidence. And this does not mean yelling at each other. Okay, that's not what that is talking about. Scientists, as they do their work, may come to different conclusions based on their evidence. And so, what we do in science is those scientists want to learn from each other. And so they share their findings and they do what we call engage in scientific argument. They each present, hey, here's the evidence that I got. And that evidence led me to this conclusion. And then the other scientist has an opportunity to ask questions about that and maybe say, well, I have this evidence and it leads me to a different conclusion or a slightly different conclusion. It doesn't mean yelling at each other. So we are going to give you some evidence and we're giving you some text. Look at this thing. We're giving you an image. All right. And then we have two kids who are going to say, based on the evidence, they think they've reached a conclusion or a claim about something. And I want you to decide which of these two students you agree with and why. Okay. And so you will write that. And finally, the last practice that scientists engage in no particular order, guys, is we obtain, evaluate, and communicate information. Because one of my favorite things to tell kids is, look, let's say you are a scientist and you come up with an amazing discovery, but you don't share it. Or you can't communicate it in a way that people can understand. So we know scientists are working on a coronavirus vaccine right now. How would we feel if those scientists either A, never communicated the fact that they had developed a vaccine or couldn't communicate it in a way that other people and physicians and scientists could understand? So this is a really big piece. Learning how to get reliable information, figure out whether or not it is good, reliable information and not just something that some random person has posted on the internet and then suddenly people believe it. You've got to go back to your source. And then the importance of communicating information. So we have a little bit of information for you, a very short video. I can't remember. I literally think this is maybe 4 minutes long. You have some questions that you can answer that go with the video. And then we thought, let's let you take a try at this. And so we're going to send you to this website, and we would like for you to analyze the website and describe whether that website is a reliable source of science information. You don't get to just write yes or no. I'm looking for at least 3 pieces of evidence from the website that would support your answer. And so I've defined what that would look like for you. All right. So I think for all of these, I'm going to go back to that module, look at it again. I believe for all of these guys, the science and engineering practices, I think for all of these except one, you are just writing in the text box and submitting it. And I might change that planning and carrying out investigations. I'm not thrilled with it. I might give you another option on there. But I think developing and using models is the only one where your submission needs to be a picture. Okay. All right, there you go. So that is it. And guys, what I would do, honestly, I would do like, I don't know, I would do like 3 of these a day. So if you do like 3 on Monday and then 3 on Tuesday, and then you'll see we have another module for you to do as well. So if you do 3 or 4 a day, you'll be fine. They're not real long each, and we've designed it. We think that that should take you, along with your starter and your vocabulary word, should take you about what it would normally take you in a class period. And for a lot of you, it will take you less time.